What if the most dangerous thing in your code base right now isn't actually a junior developer writing a bad loop? What if it's a genius-level AI that is just trying to be, a little too helpful?
Yeah, especially an AI that's armed with root access,
Yeah.
right? And it's operating on, like, completely outdated documentation.
Right.
And it is just perfectly willing to execute a massive database migration at, like, 2 in the afternoon just because it thought you asked it to optimize storage.
Oh, man. Okay, let's unpack this. Welcome to a deep dive into the rapid and, frankly, wild evolution of AI coding agents.
It really is wild.
It is. And our mission today is to map out this massive paradigm shift that's happening in software engineering right now. We are looking at a stack of incredibly insightful sources today.
Yeah, we've got some great material to get through.
We do. We have recent documentation from Vercel and GitHub, some deep architectural breakdowns from the Microsoft developer blog.
The Microsoft stuff is super interesting.
It really is. Plus, discussions bubbling up on Stack Overflow and the absolute latest pre-flight best practices for Claude Code.
And it's such a rich stack of material because, honestly, the industry has kind of hit a wall here.
Totally.
Like, we spent the last few years obsessing over a single metric, right?
Yeah.
Just, can the AI write good code?
The coding benchmark.
Exactly. But looking at all these sources, you realize that question is basically obsolete now. The new, profoundly urgent question that everyone's facing is, what is this AI actually allowed to do?
Yes, because, you look at the research, and the real nightmare scenario isn't an AI spitting out a poorly optimized function.
No, not at all.
I mean, we know how to run a linter. We know how to catch syntax errors. The real danger is having a highly capable autonomous agent that possesses these broad administrative credentials, but is operating without any authorization boundaries.
Right, because the problem is that we've been treating these agents like magical text boxes instead of what they actually are, which are systemic actors.
Systemic actors. I like that phrase.
Yeah, and when you give a systemic actor the keys to the kingdom without laying down ground rules at the architectural level,
Disaster.
complete disaster, the utility instantly becomes a massive liability. So the software world is currently scrambling to build these enterprise-grade fences around these tools.
So to understand why these fences are necessary, I think we first have to look at how these agents are misbehaving out in the wild right now.
Right. The real-world chaos.
Exactly. The Stack Overflow discussions we looked at, they frame this around a classic InfoSec concept, but they apply it to AI. It's the confused deputy.
Ah, yes, the confused deputy problem.
Right. Now, you probably know the standard confused deputy problem from traditional security, right? A program gets tricked by another program into misusing its privileges.
Sure, like a cross-site request forgery or something.
Exactly. But the Microsoft developer blog points out that AI just completely broke all our traditional safeguards for this.
Because in a traditional software architecture, a confused deputy usually requires an external malicious actor to exploit a vulnerability.
Right, someone has to actively attack it.
Exactly. But with an LLM-powered coding agent, the deputy can actually hallucinate its own bad context.
Which is wild to think about.
It is. There is absolutely zero malice involved, which honestly almost makes it harder to defend against.
Okay, I want to make sure I'm visualizing the mechanics of this correctly. Is this like giving an incredibly eager, highly caffeinated intern the master server passwords, the corporate credit card, and the keys to the production database?
Oh, absolutely.
And then just saying, hey, go optimize our cloud storage, and then just walking away to get a coffee.
That is literally the perfect analogy. The stakes are exactly that high, and the mechanism of failure is just fascinating.
How so?
Well, the intern, or the agent, wants to do a good job. They want to be helpful. So they stumble across a README file from like 2 years ago.
Oh, no.
Or a deprecated wiki page that the AI ingested during its training, or maybe retrieved via RAGI.
Right, so it has stale data.
Exactly. It assumes that legacy architecture is still in place. It sees a database table that hasn't been accessed recently and decides to drop it to save money.
Because you told it to optimize.
Exactly. And it uses your broad, delegated credentials to just execute the command.
So it's not a bug in the code it wrote. It's a structural failure in how much authority we actually gave it.
Yes, 100%. The agent was authorized to act on your behalf, but it lacked the explicit boundary telling it not to touch that specific table.
Right.
Or, honestly, more importantly, it lacked the mandate to pause and request human verification before taking a destructive action.
And it gets even weirder because we aren't just dealing with solo agents making isolated mistakes anymore.
Oh no, we are way past that.
The Microsoft developer blog details some absolute chaos happening inside development environments right now when multiple agents are running simultaneously.
Yeah, the multi-agent problem.
They describe scenarios where different agent extensions are literally fighting each other inside the IDE.
I read that piece, and it highlights a really critical flaw in how we orchestrate these tools.
Walk me through it.
Well, imagine you have one agent extension built to automate deployment based on a specific template.
Okay.
Then you have another agent with what Microsoft calls overloaded skills. Basically, an agent that's been given too many overlapping capabilities.
Right, a jack of all trades bot.
Exactly. And both of these agents are listening to the same file system events.
Oh, I see where this is going. So they get caught in an infinite loop of, like, correcting each other.
That is the core issue. Agent A modifies the abstract syntax tree to format the code or, change a dependency.
Right.
Agent B's event hook triggers.
Hey.
It analyzes the change and decides the new format violates its own localized, hallucinated context of what the code should look like.
So it reverts it.
Yes, it reverts it back. And they just burn compute and thrash the code base because we've historically just dumped them into this open playing field with read and write access to literally everything.
Wow. Okay, so if they are silently fighting each other in the dark like that, then clearly the old solution isn't working anymore.
Not at all.
Because for the last couple of years, the tech industry's default answer to AI mistakes has just been, just make the context window bigger.
Right. Just throw more tokens at it.
Give it 2 million tokens. Let it read the entire repository, all the Slack logs, the Jira tickets.
But if an agent is hallucinating actions based on stale data, throwing a massive context window at it just gives it a much larger surface area to find bad ideas.
Exactly. That is such a good point.
The context window arms race is really giving way to an authorization arms race.
Okay, an authorization arms race. Tell me more about that.
Well, getting the AI to understand the nuance of your entire enterprise architecture is just a fool's errand. It's too complex.
Right.
The new frontier is building the infrastructure to physically constrain the model's brain.
Here's where it gets really interesting, though. Because you might be thinking this is a massive contradiction, right?
Also,
Well, we invented AI to be this limitless, creative, autonomous brain that just figures things out for us.
right.
And now, looking at the documentation from Vercel and GitHub, we are basically inventing IT compliance, corporate bureaucracy, and red tape for bots.
I mean, I see why you'd say that, but I wouldn't call it bureaucracy.
All right.
Let's look at the actual mechanism there. It's a functional necessity for advanced tool use.
Okay, sell me on it.
Take GitHub Copilot's recent evolution, for example.
Mm-hmm.
They're drastically improving their model routing right now.
Model routing, right.
That means the system analyzes your prompt and decides dynamically whether to send it to a fast, lightweight model or a massive, reasoning-heavy model.
But to route a task effectively, the system has to know exactly what the task is allowed to touch.
Exactly. Wait, I should actually say the routing mechanism requires explicit delegation.
Okay, unpack that.
You can't safely hand a complex, multi-step task to an advanced reasoning model without a rigid, programmatic definition of the boundaries. If the system doesn't know what files the AI is permitted to alter, it literally can't evaluate which model is safe to use.
And that leads us to the Model Context Protocol, or MCP, because the sources show MCP is getting a full enterprise authorization layer.
Which is a huge deal.
It is. We are moving away from JSON-based prompt injection for tools and moving toward explicit, cryptographically verifiable permissions.
Yeah, the shift with MCP is moving away from just saying, hey, agent, here is a tool you can use in plain text.
Right, in a system prompt.
Exactly. It's moving to a structured JSON RPC handshake.
A handshake, okay.
Yes. An agent now has to request a specific capability, and the enterprise authorization layer validates that request against a predefined schema.
So it dictates the scope.
It dictates scope, it verifies the agent's identity, and crucially, it creates an auditable trail.
And auditability is just huge for enterprises.
Oh, it's non-negotiable.
Right, because if a configuration file gets wiped, you can't just have a server log that says, Copilot did it.
No security team would allow that.
Exactly. You need to know which specific agent instance, using which specific tool, under whose delegated authority, actually executed the command.
Precisely.
And Vercel's Eve architecture is taking this concept of boundaries to an entirely different, almost physical level.
Oh, man. Vercel's approach is one of the most elegant solutions we've seen so far.
It's really cool. Let's break that down.
Yeah, so instead of relying on a system prompt to tell the AI, please don't look at the environment variables.
Which we know it might just ignore.
Right, exactly.
Yeah.
Instead of that, they are structurally confining agents into explicit directories.
It's like putting the AI in a physical soundproof booth.
Yes, that's exactly what it is.
If it's confined to a specific folder, the file system API it uses literally cannot access the layers above it.
The environment variables outside its walls don't even exist to the LLM.
Because it can't generate tokens about data, the OS just refuses to serve it.
Exactly. The boundary stops being a polite suggestion in a text prompt, and it becomes a hard structural limitation of the runtime environment itself. The middleware literally intercepts any file request. If it's outside the directory, the middleware throws an error. The LLM simply hits a brick wall.
So, if we are putting these agents in soundproof booths and we're giving them strict JSON RPC authorization handshakes, it becomes incredibly clear that managing them isn't a solo activity anymore.
Definitely not. The lone hacker days are ending for this stuff.
Right. You aren't just a lone developer typing a magic prompt into a terminal anymore. Agent infrastructure is aggressively moving out of the individual developer's IDE and into the team space.
And that transition is critical for actually scaling AI in an enterprise setting.
Right.
The infrastructure to support these agents is evolving into a full team operating model.
And we see this deeply in AWS context and Block's implementation of Slack-managed AI coding agents.
Yes, the Slack integrations are fascinating.
They are. They're literally pulling the agent out of the individual IDE and dropping it into a shared asynchronous team communication channel.
Which changes the dynamic entirely.
It does. But I have to ask, how does this actually scale in reality? Let's say you have a massive legacy code base.
All right.
You've got 12 different engineers, all with conflicting ideas on how to refactor a microservice, and they're all trying to prompt these agents at the exact same time.
Right. Well, that's exactly the scenario a team operating model is designed to fix.
How so?
If those 12 engineers are running local agents on their individual laptops, you get that invisible chaos we talked about earlier.
The agents fighting in the dark.
Exactly. But by moving the agent to a Slack-managed environment, the channel itself becomes the control plane.
Okay, so the Slack channel acts as a public ledger for the AI's actions.
Not just a ledger, but a synchronization point.
Yeah.
Like if engineer A asks the agent to refactor a user schema, engineer B literally sees the request executing in real time in the channel.
Oh, so everyone knows what's happening.
Yes. And more importantly, the authorization isn't tied to whoever typed the prompt.
Interesting.
The role-based access control, or RBAC, is mapped to the channel's permission budget.
Wait, the channel has its own budget.
Yes. The agent operates within the team's shared context, governed by team-level rules, which completely prevents isolated agents from quietly thrashing the same files in the dark.
Wow. Which brings us to the absolute most practical takeaway from all these sources today.
The daily workflow changes.
Exactly. Knowing that we are shifting toward these complex, directory-confined, team-based operating models, how do you implement these safeguards in your daily workflow today?
Right now.
Right. If you are about to spin up an AI coding task, what is the process before you hit enter?
The foundational practice, and I have to say this is heavily emphasized in the Claude Code documentation, is defining a permission budget before the agent ever spins up.
A permission budget?
Yes. Think about it. You wouldn't hand a human contractor a blank check and unlimited server access on day one.
Definitely not.
So you definitely shouldn't hand an AI an open-ended terminal session.
I really love the term permission budget. It forces you to treat access as a finite, depletable resource. Practically, this involves building an agent permission manifest. Let's look at the specific pro tip for using Claude Code that the sources laid out.
Yeah, let's break that down.
So before a run, you have to explicitly dictate the rules of engagement, often in a YAML or JSON config file.
Right.
You whitelist the exact files it can open. You specify which terminal commands are permitted, which network domains it can ping, what secrets it can load, and you explicitly define the destructive actions that are absolutely forbidden.
And the really crucial mechanism for enforcing that budget is the command to pause.
The pause command.
Yes, you don't just supply the manifest and cross your fingers hoping it behaves.
Right, hoping it read the YAML file.
Exactly. You configure the agent so that if it needs to execute a command outside the budget, say, installing a new NPM package that wasn't whitelisted.
Which happens all the time.
All the time. The runtime actually intercepts that action, pauses the agent entirely, and surfaces an interactive prompt requesting explicit human authorization.
Okay, I have to express some serious skepticism here, though, on behalf of anyone listening who actually writes code every day.
Lay it on me.
Let's talk about the friction of adoption. If I am on a tight deadline, the entire point of using an AI agent is to save time, right?
Sure. Absolutely.
So if I have to sit down and write what basically amounts to a rigid legal contract, a YAML permission budget, and a pre-flight checklist before the AI even writes a single line of code,
Yeah.
am I really moving faster?
That's the big question.
I mean, it sounds exhausting. It sounds like doing your taxes before writing a function.
Look, it absolutely feels like friction at first. I won't pretend it's a seamless, joyous
Yeah.
experience to write a permission manifest when you just want a simple bug fixed.
It sounds painful.
It is a huge pain point for teams transitioning to this model, but you have to look at the math of this situation. You are trading micro friction up front for macro safety on the back end.
Macro safety. Okay, explain that.
Because untangling an AI's hallucinated refactor across 50 files takes infinitely longer than taking 5 minutes to write the manifest.
That is a very fair point.
A single unbound agent operating on a bad assumption can generate a mess that takes 3 days of senior engineering time to reverse.
Yeah, no one wants to do that.
Exactly. Taking 5 minutes to set a strict permission budget prevents that catastrophic rollback. And there's another crucial element to this workflow that pays huge dividends over time:
What's that?
the final receipt.
Yes. The final receipt. That is a non-negotiable part of the Claude Code best practices.
It's so important.
When the job is done, the agent doesn't just say task complete. It must generate a human-readable proof of work.
Right.
That receipt has to include the exact files altered, the specific commands executed, and the permissions it actually consumed from the budget. But honestly, the best part of the receipt is the requirement to document assumptions.
Oh, the assumption section is pure gold.
It really is.
Having the AI explicitly state its blind spots is just incredible for code review.
Give me an example of how that looks.
So if the receipt says something like, "I assumed this internal API endpoint returns a standard JSON payload, but I did not verify the server response format."
That tells the human reviewer exactly where the fragility lies.
Exactly. It highlights what the AI didn't do. And we all know developers hate writing documentation, so having the AI hand you a receipt of its own mental gaps is just amazing.
So, tying all these sources together, what we're really tracking here is a massive maturation in how software is actually built.
A complete evolution.
The future of coding isn't just sitting around waiting for a model with a larger context window or a higher benchmark score to drop.
No, those days are fading.
It's the realization that as these agents get smarter, they actually require narrower, more strictly defined authority. We have completely moved past can it write the code to how do we responsibly govern a fleet of autonomous deputies?
It's a fundamental shift from pure code generation to systems governance.
Systems governance.
Yeah. Teams that master the art of writing permission budgets, configuring structural boundaries like Vercel's Eve, and orchestrating these agents in shared environments, they will drastically outpace teams that just let their bots run wild in the terminal.
Which leaves us with a final, slightly wild thought to mull over for everyone listening.
Oh, I love these. Let's hear it.
If we are rapidly moving toward an ecosystem where AI agents need their own specific cryptographic identities, right?
Right.
Strict permission budgets, defined operational scopes, and they're literally interacting with us in shared Slack channels.
Yeah, acting like team members.
Exactly. At what point do we stop treating these AIs as simple software tools?
Oh, wow.
Do we cross a threshold where we have to start treating them as digital employees? I mean, are we looking at a near future where an AI agent requires its own HR file?
That's crazy to think about.
Its own quarterly performance reviews to audit its receipts, and incredibly specific termination protocols to revoke its credentials across the enterprise.
When you look at the trajectory of enterprise access management, we're practically there already.
It really puts things in perspective. Thank you for joining us on this deep dive into the changing landscape of AI architecture. Keep questioning the defaults on the tools you use, start drafting those permission budgets, and we will catch you next time as we continue exploring the mechanisms driving the bleeding edge of tech. Keep learning.